Okay, so today we're going to be doing 4.3, which is some rules with probability. If you remember, we talked about probability basics in 4.1, and then yesterday we talked about events in 4.2, and now we're going to be putting these ideas together. So we want to look at this notation here. If E is an event, then P of E, we would read that as the probability of event E represents the probability that event E would happen. So some situations where this would come up. Let's say that an event is, we roll a dice, and the event is that a number that is rolled is even. So we want to find the probability that if we roll a dice that the number is even. Well, there's 1, 2, 3, 4, 5, and 6. So there's 6 possible outcomes. 4 of those possible outcomes are even. So we would say, or 3 of those possible outcomes are even, so we would say the probability is 3 out of 6, or 1/2. In a different situation, when selecting a card from a deck of cards, find the probability of B if B is that the card selected is a club. Well, if you go to the deck of cards, there are 13 possible clubs out of 52 cards. Well, and that also reduces to 1/4. So the probability of B happening would be 1/4 of the time. And then when selecting a digit could be anywhere from 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. What is the probability of C happening if C is that the digit is a multiple of 3? Multiples of 3 would be 9, and 6, and 3, and even 0. And that's 4 out of 10. So we'd say the probability of selecting a digit that is a multiple of 3 is 4/10. So let's take a look at some other situations that can come up here. First of all is the probability of A or B. And this rule only takes into account events that are mutually exclusive. So if we have 2 mutually exclusive events, we would just add those probabilities together. For example, let's say that the probability that somebody at Homestead is a freshman is 26%, and the probability that somebody is a senior is 23%, then if we said what's the probability of somebody being a senior or a freshman, we would just simply add those two things together, and that would be 49%. So that's a special addition rule. That also works if there are 3 events or more than 3 events. As long as all of the events are mutually exclusive, we would just add those probabilities together. So for example, if we wanted to find the probability of D, E, and F in this situation, we have sizes of farms, and so it could be a farm that's under 10 acres or 10 to 49 acres and so on. But if we want to know the probability that they're in D, E, or F, those events are all mutually exclusive. The probabilities are here because this is a relative frequency table. So we would just simply add 0.167, 0.068, and 0.042 together to find the probability of a farm being in the category of D, E, or F. All right, so here's another rule. This is called the complementation rule. And that is if we know the probability of event E, then the probability of not E is always going to be 1 minus the probability of E. So for example, let's say that the probability of reaching in a bag and getting a blue marble is 1/3. Well, what's the probability of not getting a blue marble? Well, that's 2/3, because I would just take 1 minus 1/3. And that's the complementation rule. And then we have, well, let's just take a look at something like this. If we want to find the probability of not K. So here, if K is that an event, that a farm selected is 50 acres or more. So that would be all of these categories here. So all of this would be K, and I could find all of these probabilities to find the probability of K. If I wanted to do that, I could do that and then just go 1 minus K to figure out what the probability that a farm is not 50 acres or more, or I could just simply add these two together. And I would be able to find the same probability that way. And this is probably the most complicated general rule that we're going to have today, and that is for any events A and B. They don't have to be mutually exclusive. If I have the probability, if I'm looking for the probability of A or B, I could add the two together, but then I have to subtract the intersection of those two sets. Here's an example of what we mean by this. Suppose A is that a card selected is a spade. That's all of these cards here. Then event B is that a card selected is a face card. That's all of these cards here. So there are 13 spades and there are 12 face cards. So we want to know what's the probability that a card selected is either a spade or it's a face card. Well, if I took 13 plus 12 and I added them together, that would be 25 cards. But there's not 25 cards there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 cards. So how come there are only 22 cards? Why can't I just add them together? And that's because these 3 cards here were counted twice. They're in this 13, but they're also in this 12. So instead of counting them twice, I have to subtract those 3 cards. And those 3 cards are the intersection of those two probabilities. And so I would take the probability of A, which is 13, plus the probability of B, which is 12, and I would subtract the probability of A and B, which is the intersection of those two things, which is 3 cards. And that would give me 22 cards out of the 52 total. And that's why we're subtracting the intersection of those two sets when we find the probability of A or B. We only have to do that when the events are not mutually exclusive. Mutually exclusive events, I mean, it wouldn't make sense anyway because there isn't that with mutually exclusive events. So that's going to be an important rule for us to remember when we're finding the probability of A or B. So let's take a look at this situation. One year, 73.9% of the people arrested were males. 12% were under the age of 18. And 8.5% were males under the age of 18. So this would be the intersection. Okay, that's A and B. Okay, 8.5% were males and under the age of 18. 73% were 73.9% were males. I'm going to call that event A. 12% were under the age of 18. I'm going to call that B. And so I guess we're doing that here. M is the event that a person is a male. E is the event that the person is under the age of 18. We want to find the probability of M or E. So we're going to first take the probability of M. Then we're going to add the probability of E. And then we're going to subtract the probability of M and E. So the probability of just M, probability that that the person was male, was 73.9%. Then I'm going to add to that the probability that somebody was arrested was under the age of 18, that's 12%. But then I want to subtract the intersection, which is 8.5% of the time. They're in both groups. So I'm not sure what that comes out to be, but whatever 73.9 plus 12 minus 8.5, that's going to be the probability of M or E occurring. And that is lesson 4.3. So we can finish that up and work on the Math Excel homework assignment for 4.3, and we'll get together again tomorrow.